Okay, let's continue on with our discussion of Memoizers. So if you recall, last time we talked about the design of a Memoizer, which is a class that we use to associate values with keys that we've already looked up before and computed the results. What we're going to do now is we're going to talk about how to implement the Memoizer using the Java ConcurrentHashMap. And the purpose of this, as you'll see when we look at the next part of the lesson, which we'll talk about applying this in the context of the prime checker application, the purpose here is to cache long-running function call results and then return these cached results for the same inputs, thereby speeding up performance of the code considerably in some cases. So you're going to see here that we are going to implement the Memoizer to use a concurrent hash map in order to ensure that long-running computations only run one time and are then cached thusly. So here's the Memoizer. It's a generic class with a key and a value. It implements the function interface, which is a functional interface, so you can use this anywhere a function is expected, function being a generic type that's defined as part of the Java 8 functional interfaces. We have a map that's going to be used to associate a key with a value, and where the value is produced by a function that operates on the key. So this is the cache. We stash the function, which will be passed as a parameter, as you'll see in a second. And this is the thing that produces the value based on the key. And then the constructor takes a function, and it takes a map, and it stores those things in fields. And we do this so it's possible to parameterize the map and the function with different kinds of mechanisms. And I mostly do that, not so much because we need it to be parameterizable, but I have a cool little test program that demonstrates the difference in performance between using a concurrent hash map, which, as we'll see shortly, has all these clever optimizations, and a traditional synchronized map, which does not have all the clever optimizations. So needless to say, the concurrent hash map version is a lot more efficient. Here is one of the methods. This is called apply. Apply is the method that's implemented from the function interface. And what it does is it takes a key, and it goes ahead and it returns the value that's associated with the key in the cache, if there is one. So let's take a look at how apply works. As you can see, it's passed in a key of type E for element. Actually, of type K for key, for key. Here is the method call that apply does. What it does is it uses the concurrent hash map, which is what we had stashed away over here in the constructor. And we then called the computeIfAbsent method. Now, the computeIfAbsent method is a very cool method that's only available in Java 8 and beyond. And we'll come back to that later when we talk about future task. But if you're using modern versions of Java, then computeIfAbsent has this really cool semantic. And what it allows us to do is it allows us to have multiple threads all simultaneously calling computeIfAbsent for the same key that has not yet been added to the map. So it's a non-existent key in the map. And what will happen here, because of the semantics of computeIfAbsent, is that only one of these calls will actually have the effect of calling a function and then storing that function's result in the map. So this is a very cool mechanism known as an atomic check then act, or check then conditionally act, or conditionally check then act. And we'll take a look and see how computeIfAbsent works later. And I'll actually show you how to implement a version of computeIfAbsent using future task if for some reason you don't have the benefit of using modern versions of Java. So computeIfAbsent has this really cool semantic. What it does is it goes and tries to find the key in the cache. And if it can't find the key in the cache, then it goes ahead and atomically calls this function. And the key thing to note here is that the checking to see if the key is in the cache and the calling of the function is all done atomically, and only one thread will actually do this. All the other threads have to wait until this function is finished computing, in which case they will be the beneficiary of the result that that function produced. So you can think of this as something called lazy initialization. So we only compute the function if, in fact, we don't already have a value in the map with that associated with that key. So what's going to happen here is the first thread in for a given key won't block. It'll go ahead and call the function and figure out what the value should be that's associated with the key by calling the function. But any other threads that come in at the same time and also don't find a key yet, so the key is non-existent in the map, they will all have to block until the first computation is finished. And then when they're unblocked, they will just read the result out of the map and they can continue on their merry way. So this is a very powerful method. We will look at a way to implement it later, but for right now, we're just going to use the one that comes out of the box from Java ConcurrentHashMap. So the result of the apply method is simply the value which was looked up in the map if it had been pre-computed earlier, or if we've just computed it. In either case, we're going to return the value that's associated with that key. And that, in some sense, is really what a cache is all about, right? You check to see if something's there. If it's there, you return it. Otherwise, you do something and then store it into the cache. There's also a method here called remove, and you can see that all this does is it simply forwards to the remove method on ConcurrentHashMap and says, please atomically remove the key and value that's associated with this key. So that removes the item from the map. So that's the overview of how to implement a Memoizer. And as you can see, this particular implementation is really quite simple and short, and that's because we're leveraging the computeIfAbsent method that's defined on ConcurrentHashMap. We'll come back later and see a different way to implement this that uses other features if you aren't fortunate enough to be able to use Java 8 and beyond.